Hey all, welcome back. I hope you are doing great and awesome out there. Good evening to everyone, and we are going to continue with the same discussion that we were having in the prior class, and we'll be doing CAD and CAM today. I've had a sore throat now, pardon me for a distorted voice. All right. Okay, so we are going to have important questions discussion. This is the part 3. All right. And this is my profile. My name is Rahul Kanyal. I've had the opportunity of working in a PSU called BHEL, and after that I've had a master's degree from IISc Bangalore, and here I am in front of you believing that I can give information and knowledge whatever I have received, and it's a very noble cause, and I hope you're doing really great out there. Let's see how it goes. Okay, you can join our live analysis ESC 2020 on 5th of Jan, and as you can see, and we also are coming up with mega mock challenges like this. Okay, fine. Okay, so number of days for ISRO are 12. I hope that you are really pumped up out there. You are trying your best. You are taking sufficient rest so that you give your best out there. All right. Okay, fine. So let's start with this. Yes. Okay. In computer-aided drafting process, an arc is defined by. Can you please come up there? What should be the answer for this? What is an arc? So I'm going to start. An arc, right? So can it be defined using two endpoints only? Can it be? Okay, fine. See, to define an arc, so let's say this is an arc. Let's say you just have two endpoints, and one arc can be made like that, another arc can be made something like that, and another arc can be made something like that. So this is not a valid option, right? Let's say we have this arc and we have a center and a radius. So arc is defined by arc length and radius. Yes? All right. So, okay, Amit says D. Aditya Srivastav says no, sir. I don't know what that means. Amit Garg says no. Okay, fine. Now, okay, can you please tell me what is. Okay, center and a radius is required to define a circle, right? But not an arc. Yes? So, this is not an option. Radius and one endpoint. No, this is not further very true. Two endpoints and center. So let's see. So when point A and point B are decided, and we also have a center, so radius is already decided if we have a center and two endpoints, because we can calculate the radius from as the distance of point B or point A from the center. So D is a good option. Yes? Okay. Fine. So lots many answers. I congratulate you, those who said D. Okay, fine. Now why you should be watching this? Because of these 2 marks. Okay, I have been repeatedly telling you that if you can score 2 more marks, your ranks will soar up. Okay, yes. Yes, Ashwini, you are right. And Ganesh and Amit, Aditya and Mageshwaran, you all are right. Okay, next question. Please try this. You have 2 minutes for this. Okay, fine. Dharmendra, yes, you are right. Congratulate. Yeah. Can you please try this? Can you please try to answer this? Don't take more than 2 minutes. Hello, Suman. Please try this. Come on, come on, come on. So what is the answer? What is the answer? Mahato says A, Deepak says B, Praveen says D. Okay. Let's see. Okay. Ganesh says A. Mahato, the Vijay says A. And more answers. Come on. More answers for it. Just try to make it, okay? Okay, fine. Let's try to make this. Okay, let's plot P1 first. 15, 10. Let's say this is 15 and let's say this is 10. Okay. So this is 15, 10. Yes, this is P1. Where should be P2? Somewhere 10, 15. Let's say this is 10, 15. All right. Now clockwise circular arc of radius 5 is made. It should look something like this. All right. Because this is 10, 15, as you can see, this distance from here to here is 5. All right. And this distance from here to here is also 5. Yes. So this is the center of this arc. Right? Yes. So we have to just find the coordinate of the center. So what should be the coordinates? Can you give me? This is 15 and this is also 15, right? Yes. C, yes. So this coordinate is 15, 15. Those who said 15 or C option, those are correct. Yes. And now guys, please don't make an error in a simple question like this. That's why I keep on telling you, you are here for these 2 marks. All right, you are here to not do any silly mistakes, because fewer of you got C. Ram, yes. Vikas, Suman, okay. Mageshwaran, Hardik, fine. You got C. Okay. Fine. Now from P1 to P2 you have to go, right? This is P1, this is P2, and it says clockwise. So this is the only option. Right? Deepak. Hello Bijendra. I welcome you here. I welcome to this session, okay? Is that good? It says clockwise circular arc. Fine. C. Fine. Yes. Okay. Now tell me this. Update of, please don't expect the exam to be delayed. You just prepare for the dates and give it to them, because it's not in your hands, Hardik. This is what I can suggest to you. Just prepare, stick for these 12 days. Okay, don't expect that it will be delayed or I don't know what. Okay, because it's not in your hands. Let's see when it comes up. Let's see when admit cards come up. Your job is to prepare. Their job is to send you admit cards. I hope I am clear. Okay, yes. Fine. Now, which among the NC operations given below are continuous path operations? What is continuity? Let me ask you. What do you understand by continuity? Then you will be able to understand what is continuous path operations. Yes. Please come up. Sharmila says A. Okay. Aditya says B. Okay. Revision tube says B. Okay. Mahato Vijay says A. Fine. Ashwini says B. A. A. No idle time. What is continuity? Let's understand this continuous path operation first. What is continuity? Let's say in mathematics you understand continuity, right? Well, what is continuity? What is discontinuous? Right? Then only you will be able to answer this. Otherwise, most of you are getting it wrong. And fewer of you are getting it right. This is what I can tell you. Okay. For example, see, I'm going to ask you a question. See my movement, the movement of this digital pen. Okay. See this. Is it continuous? Yes or a no? Please write in. Yes, Yaneshwar said without break. Yes, he is right. So is it continuous? Yes or a no? Just type in yes or a no. That's all. This is what I want to know from you. All right. Yes, continuity means no break. Exactly. So was this a continuous motion? Suman says yes. Breaks makes the movement discontinuous. Okay, fine. Yes, yes. Just say yes or a no about this movement. Yes, exactly. Yes. Fine. Fine. And more options. Can you please come up? Okay. Okay. So arc welding, is it continuous process? I made an arc to you that you said is continuous, and if I do something like this and lift it, then make it, then it's a discontinuous process, right? This is continuous. So arc welding, is it continuous? It is continuous. Milling, is it continuous? Is it continuous? It is continuous, right? You are not lifting up the tool, the cutting tool. You are constantly doing it. Yes? Okay. Drilling, is it continuous? Yes or no? Is drilling continuous? Drilling is not continuous because let's say you have to drill hole like this. So firstly you drill hole here, okay, then you retract the tool like this, move it, then drill it. There's no continuous movement. So drilling is not a continuous process. Yes? Is punching continuous? No. Laser cutting, what happens in laser cutting? It's a continuous process. Alright, so this is continuous. Spot welding again is not continuous. What we have is AW, LC and M. So first is the option. See, still I am telling you, these are just general questions. You should not be erroneous about these, okay? Please think before answering. Be careful, okay? You can do it. It's fine. Even if you are making errors, you can do it. All right? Is that good? Is that good? Yes. Parimal also says A. Generally, you don't drill one hole. That's why it is. Okay? Nitin also says that. Okay, fine. This is just a common sense question. Okay? So, this is how it is. All right? Okay, let's continue. Now, during the execution of CNC part program block N02, this is written, the type of tool motion will be. Quickly answer this. Come on. Quickly. Quickly, come on guys. Yes, I gave you an example, Ashwini, in the last slide. You have to lift the drill bit, right? For example, you have to do this. All right? That's all. Okay. Fine. Now please answer this. Okay. Nitin says A, Meheto says A, Vikas Kumar says A, Vineet says A, Paila says B. Okay. So, what is this? Can you tell me what is this? N020? What should be the answer? What should be the answer? A. Okay. There's a clash between A and B. So, which one is correct? Come on. Line number, yeah. Sharmila says this is line number. This is just line number, okay. So, G02, is it clockwise or anti-clockwise? It is clockwise. Circular interpolation clockwise. Alright, it's A. Yes, that is serial number or line number of the program that you're writing in. Okay, now please don't lose your 2 marks in this or 1 mark in this. This is very easy stuff. Okay, G02 is clockwise, G03 is counterclockwise. Alright, please don't lose marks in this. Okay, so I congratulate all of you, those who said A. Okay, good, you did well. Now let's see how do you do in the next question. Alright, so how are you doing there? Are you guys good? Okay, let's move. Fine. Now, please try this. Yes, Venkat, I get you. A is the option. Good, yes. So these are few of the common questions that you can expect in any examinations, okay? Fine. Yes, good, Aditya and Sandeep. Nice. Yes, it's good to hear you. Vineet, Suraj, good, nice. Please try this. Even I don't have any idea when you are going to get admit cards, okay? Really speaking, I have no idea about that. I suggest that you prepare, you do your karma. You prepare for it and you will get admit card one day. It's their headache to send you admit cards, right? Okay. Thank you, Hardik. Thank you. Thank you for your wonderful, inspiring comment. I am, you know, what do I say? I feel good about that. That's all. Okay, fine. Yes, please. Can you please attempt this? B. Mangeshwaram says B, he is not very much sure, okay. Meheto the Vijay also says B, okay, fine. And let me tell you that it's not always that you know everything from the beginning. Sometimes you have to assume. For example, this thing, positioning accuracy, if you don't know, you have to assume it. Okay, and let me give you an insight into it. Calculate whatever you can calculate. Okay, if you're not getting what is the meaning of this and you leave the question, don't do that. Okay, firstly calculate what you can calculate. Okay, option B, people say, okay, can you please try again if you're not getting the options. So firstly write it. All right, if you can write it down, okay, fine. So 1 pulse corresponds to 1 degree, right? And the pitch of the lead screw is 3.6 mm, which means in 360 degrees the lead screw moves by 3.6 mm, right? So okay, let me make it consistent over here. I'm going to write degree. All right, 360. Okay, let me erase it again. 360 degrees correspond to 3.6 mm because pitch is given. Okay, pitch means that how much the table moves in 1 complete rotation. Yes, okay, fine. We are coming into it. Okay, we are coming into it. Many says that B should be the option. Okay, fine. So in 1 degree, it will move how much? 3.6 upon 360 mm, right, equals to 1 upon 100 mm. Yes? Alright, so in 1 pulse also, it will move this much. That is nothing but 10 microns, right? You can see it. B is the option. Alright? Alright? This is called positioning accuracy. Sometimes accuracy is also, even if accuracy and sensitivity, not sensitivity, the resolution. Accuracy and resolution are used interchangeably here. Alright, so I'm going to repeat it. Sorry, I messed it up. Sometimes, accuracy and resolution are used interchangeably. Okay, sometimes they might also say, okay, positioning resolution, how much is it? So you have to calculate the same. Okay, this is also called basic length unit. Okay, how much the table moves in 1 pulse, that's called basic length unit. All right. Yes, you're right. All of you are right. Let's move ahead. I congratulate you. Yeah, this time everyone got it. Okay. This was a bit tricky, but everyone got it, and it's really nice. All right. Yes, let's move. Okay, this is the question that we had already done last time. Okay, can you please try this? We had understood the concept of rotational matrices in the last class. So can you please try that with this? Come on, can you please do it? Do you understand the question? A point P is translated by 2i plus 3j minus 4k and then rotated counterclockwise by 90 degrees about the z-axis. The new position of the point is, can you please try it? Come on. Okay, Vineet says A, minus 6, 3, minus 9. Fine. Okay, let's see. Come on, come on. You have, Vikas says B, is it? Okay. Okay. Fine. You have 1 more minute. Vineet, congratulations, you have done it. But I'm not sure if you have correctly evaluated it or not. Let's see it. Let's take it forward. Okay. Aditya Srivastav says A. A. Okay. Okay, fine. Okay, so if it is rotated counterclockwise about the z-axis, it means that it has a rotation in xy plane. So what does that mean? Okay, we'll come to it. Fine. Firstly, the point 1, 3 minus 5 is translated by 2y plus 3j minus 4k. So I'm just going to write the coordinates over here. 2, 3 minus 4. Okay, this is translated by this. So what do we get? We are just going to add them, right? Yes. Okay. So 3, 6, minus 9. So this point, when translated by this vector 2i plus 3j plus 4k, becomes this coordinate. You can also write it in terms of a vector. Yes. Now, if this point is rotated about the z axis, that means that the point is rotating in xy plane. Yes? So what does that mean? The z coordinate will be the same, like this. Z coordinate is going to be the same. So here z coordinate is same in this, and in this. Only x and y coordinates are going to be changed. Yes, this is what it means. Yes? Okay, fine. Now we said that rotational matrix is nothing but cos alpha minus sine alpha, and cos alpha, where alpha is the angle of rotation counterclockwise. All right. So alpha here is 90 degree. Alpha is equal to 90 degrees. So Rm equals to, just put it over there, 0 minus 1, 1, 0. Okay. Fine. Yes. Now 3, 6 minus 9. So 0 minus 1, 1, 0. What was the point here? The point was 3 and 6. And 6 equals to how much? Minus 6 and 3. Yes? This is the final point. This we have already discussed, the rotational matrix, I think in the last class. All right? Yes? So minus 6, 3. Minus 6, 3, and the z coordinate is already going to be the same, which is minus 9, right? This one, because of its rotation in the xy plane, right? This is how you do it, right? So the final point in 2D, minus 6, 3, minus 9, should be final point in 3D. So A is the option, right? Yeah, Z should not change because it's about Z axis. So I congratulate all of you, those who got A: Aditya, Vikas, Mehato, Saeed, Vineet, okay, Hardik, every one of you. Fine, yes? Yes, only XY changes. Is that good? Okay, fine. Yes. Okay. Is that good? Should we move ahead? Any questions in this? If it would be about x-axis, then the x coordinate would not change. You can try that even. All right? Yes, only y and z would have changed here. Okay, fine. Is that good? Hello? Okay. Now, can you please try this? This is mirror imaging. You have 1 minute for this. Please try this. Come on. Please try this. Yes? Yeah. Mato says B. Okay. Okay. Fine. Good. Shamila says B. Vineet says B. Okay. Good. And come on, come on, rest. Okay, can you please identify which one is this line? 45-degree counterclockwise with the x-axis. What is this line? There's a line. We are talking about this line, 45-degree, passing through the origin. So what is the equation of this line? Right? What is the equation of this line? Come on. X equal to y. Yes, Vineet, you are right, because the slope is nothing but tan 45 degrees. That equals to 1. Yes. So this is y equal to x line. I hope I'm clear. Yes, good. Aditya, Vikas, I'm okay. Very happy that you're following it up. Fine. Now 5 comma 10. Okay, now let's assume that this is y equal to x line and this is a point 5 comma 10. All right. Now you have to select out of these 4 points. Okay. Let's say that alpha comma beta is the image of 5 comma 10. Yes. So the midpoint of these two coordinates should lie in y equal to x. Agreed. I'm going to repeat it. The midpoint of alpha beta and 5 10 should lie in y equal to x because these are the mirror images. All right. Yes. Fine. So what is the midpoint? Let's say this is the midpoint x comma y. So no, not x comma y. I don't want to generalize it. Let's say this is a comma b. So a is 5 plus alpha upon 2. Right. B is 10 plus beta upon 2. Yes or no? So out of these options, what option follows 5 plus alpha equal to 10 plus beta? Which one of the options follows this? Right. So as we go down, this is the option that follows it. Right. Alpha is 10, alpha equal to 10, beta equals to 5. Yes, this is how it's solved quickly. Did you solve it this way? Hello everyone. Okay. Is that good? Yes, that can also be done. Yes, that can also be done. All right. Yeah, it can be done this way. Okay. Yes, from metrology you can expect 3-4 questions. CAD CAM maybe 2 or 3. All right. Yeah. So as I've told you, you are coming here for 2 marks this session. What if similar question pops up in there? Your rank will be elevated. This is what I keep on telling you. All right. That's why these sessions are so important for you. Okay. Yeah. Fine. Now, let's say there's a point xy. Okay. If you take its reflection about the x-axis, it becomes x comma minus y. Yes. So what it means is that, can you find a matrix? When you multiply it by xy, it gives you x minus y. So this matrix is going to be, the order of this matrix is going to be what? Can you please come up with this? Yes? This matrix that we are going to find, this is nothing but the transformation matrix. What should be the order of this matrix? Okay, fine, Vineet. Okay, I'll come back to you. Fine, fine, fine. Yes, you might be right. You're close. Yes. So can you find this matrix? One zero zero minus 1, 2 by 2. Suraj says 2 by 2. Yes, it's going to be 2 by 2 because if this is 2 cross 1, then only it will be a 2 cross 1 matrix, right? Yes, you're right. You're right. So can you please, yes, Aditya? Okay. Yes, so most of you have given the answers. Okay. 2 cross 2. Okay. So I'm going to write, because we need one x here, so I'm going to write 1 0 0 and minus 1. See if it follows it. Yes. Yes, yes, yeah. And you can obviously calculate this with respect to y-axis as well. This is how it is. 1, 0, 0, minus 1. Okay, so this is kind of, you almost all of you got it. Okay, almost all of you got it. Fine. Yes. Yeah, you can also rotate it by 180 degrees, right? Sitaram says. Yeah, obviously that is also allowed. Okay. Yes. Should we move ahead? Fine. So y-axis, similarly, you can find it out. Okay. The idea you have gotten, I think. Okay. For the following scaling operation, let's say this is xy. Let's say this is 2x comma 2y. Can you find a matrix that when you multiply it xy, it gives you 2x 2y? This is what it means. Can you find a matrix like that? Come on. It's similar. It's very much similar. 2002. Okay, good. Good, Vineet. Good. You're doing good. Nice. Two 2002 Mageshwaran says, okay, fine, good. Yes. 1001. Okay. Ashwini, okay. You might want to check that when you multiply this with that. Okay. So most of you are getting this. Good. So most of you are getting this. So I'm going to write here 2002. Let's see if it's true or not. Right. So when we are talking about scaling, scaling means making something big or small, bigger or smaller. Okay, as you can see, this square over here is made twice the size. All right, in terms of length I'm talking about. Okay, so always remember that a scaling matrix is a diagonal matrix. All right. Yes, Ram, I think you're right. Sita, even you're right, 2002. So I'm happy that at least you are getting this. All right, all of you are getting this. Fine. Fine, now let's try this. Yeah, Mageshwaran, I think we are having some technical issues. No, row 2, actually 3003 will be done when we are making it thrice big. All right, 2002, why 2? Because we are making it twice as big. Okay? Yes. So can you please try this? It is similar to the pitch problem that we had done. The positioning, okay, I'm really sorry for this if this is happening. Is it fine now? I hope this gets better with time. This is what I can do. Oh. Okay. Aditya has even come up with this answer and it's good. Vidita, let me check. Okay, fine. They must be working on it. Our team must be working on it. Just hold on. It seems to be a technical glitch out there. A small technical glitch. I don't know if it's going to help or not. Mageshwaran says A. Okay. Okay. I hope that I'm audible and I am. You can visualize me. You can see me out there. Yeah, there seems to be a technical glitch. Okay. Fine. The Vijay says B. Okay, fine. Whatever happens, I'm going to complete this. Okay. Now pulse rate equals to number of pulses per second. This is how it is. Okay, but there isn't any mention of the pulses over here. So how do you approach this? See, it says that it has 300 step angles. So I told you one trick. You just write what you can write. You calculate what you can calculate. All right? Okay. Mato says B. Okay, fine. So I think this glitch has continued. So I'm going to complete it quickly. So it says that 300 step angles correspond to 360 degrees, right? Right? Because it's a motor, it rotates. So there are 300 step angles that corresponds to 360 degrees, and 360 degrees further corresponds to, it has a pitch of 5 mm. Right? Yes. So this means 1 mm corresponds to 360 degree upon 5 equals to no. Okay, let me write this. So which means 300 step angles correspond to 5 mm. So 1 mm corresponds to 60 step angles. Yes, now it's given over here 200 millimeter per minute. So in 1 minute the table moves by 200 mm. Yes. So in 1 second, okay, so in 1 minute this goes by 200 into 1 mm correspond to 60 step angles. I am going to write it 60 step angles. Yes. So in 1 second it will correspond to how much? 200 step angles. Right? So we can write that, or we can conclude that in 1 second 200 step angles are being covered up. Okay. Okay, fine. It seems there's a problem in the upstreaming. I hope that this is taking place, but still I need to complete this. So let's carry forward. Okay. So but we have to calculate this number of pulses per second. We have calculated number of step angles per second, right? In 1 second, how many step angles are being traveled by the motor? This is what we have calculated over here. But there's no sign of any pulse, so we just need to make an assumption that 1 step angle equal to 1 pulse. Otherwise, there's no way by which we are going to calculate step angle by pulses, okay, or pulses by step angles. Okay, so this is 200 hertz. So B is the option over here. All right. Okay, fine. So this is all from our side from this, and I really apologize for yeah, I really apologize for this stuff that the streaming has stopped or hindered, but I hope that I had given you something to think about. All right, and I wish you all the best for your ISRO. Yes, Aditya, answer is B. You are correct. I think, yeah, most of you said B. Mehta also said B. Mogeshwaram said A, but yes,